Hello guys, welcome to Bugs in Code. The problem that I'm going to explain today is even swap. But before that, if you are new here and a person who likes stuff related to coding, then you can subscribe the channel so that you get notified when I push a new video. Okay, so let's get started. Here is the problem statement and it says that you're given an array A and you need to generate an array B. Okay, you're allowed to apply only one type of operation on the array A any number of times. Okay, in one operation you can swap AI and AI plus 1 if the sum of both is even number. Okay, array B should be generated after applying the above operation any number of times on array A, and the array B should be lexicographically the largest among all the arrays that can be generated from A after applying the above operation any number of times. Okay, so an example is given here. Let me explain the example. Okay, so I have the example and array is given to us. Array is like 1 3 5. Okay, so I can apply the swap operation on two adjacent elements if the sum of both is even. Fine, so I can see that I have two adjacent element and the sum of both is even, which is 4, so I can apply swap operation. So I will get 3 1 5. Okay, again for this I can see that the sum is again even and these are adjacent elements, so I'm going to apply the operation again. I will get 3 5 1. Okay, and now one more thing that I can notice is again here the sum is even and these are adjacent elements, so I can again apply operation. So I will get 5 3 1, and even this 5 3 1 I can again apply operation. I will get 5 1 3. So there are multiple strings possible, but among all of them you can see that this is the largest possible string. Why? Because largest possible number is 5 here, and if you move 5 to the leftmost index, then I will get this as the lexicographically largest possible string. Now I hope the problem statement is clear to you. Let me talk about the solution now. Okay, so we will start with the intuition first. Intuition. Okay, so let me draw an array which is take the same from the example, which is 1 3 5, and now let's consider it as a1. Okay, and now I'm going to again draw one more array which is okay, let me take 3 1 5. Okay, so if I ask you which one is lexicographically larger, so which one is larger, what you are going to say? You will say, okay, fine, this one is larger. On what basis you are saying that? You will say that, hey, you can see element on the left of this array is greater than the element on the right of this array. Okay, fine. So till now I know if the element on the left is greater, then I will get a greater lexicographically like greater string or array. Okay, fine. So I can write it. I can write it. Till now I know from the problem statement that my condition is if my a of I plus a of I plus 1 is even, like mod 2 is double equal to 0. So I can swap. I can swap. Okay, fine. But I'm going to modify this condition. I'm going to modify this condition. On what basis I'm going to modify this condition? I will say that if my left element is smaller and right element is greater, only in that case I'm going to like swap two numbers. Why I'm saying that? Because if like in the input I have this array itself instead of this array, so I have 5 3 1 as my input. So is there any need to perform the operation? I don't think there is any need to perform the operation. It is itself the lexicographically largest array possible. Okay, so we can modify this condition. We can modify this condition. I will say and array of I, which is left element, is smaller than array of I plus 1. Now this is very important. If I have like smaller element on the left and larger element on the right, so I can swap them and then I will get larger element on the left and smaller element on the right, and this is going to be lexicographically greater possible string. Listen, I'm saying greater, I'm not saying the greatest possible. Okay, so now this is the condition that I have modified. Fine. Now we are going to use this condition. how we are going to use it. Let's talk about the first approach now. So the first approach that comes to my mind is, let me write the like heading for this. It's going to be brute force approach. Brute force approach. Okay, so first approach that comes to my mind is, I can iterate over all the elements in the array. So for every element, like I small equal to 0, I smaller than n minus 1, and I plus plus. Why I'm writing n minus 1? Because I don't want any index out of bound error, because I'm going to check I plus 1 index as well. Okay, fine. Now I will check the same condition that I have explained here. Like, I'm going to check the same condition. So let me write the condition. If a of I like plus a of I plus 1 is even, like is even, and a of I is smaller than a of I plus 1, fine. In that case, I will swap. Okay, and when this loop completes, then I will have lexicographically greater string. I'm not saying greatest, I'm saying greater. What does this mean? It means that if I have the input array as 135, so when this loop completes, I will it will start from this point, and it will say, okay, condition is true, so I will do 315. Okay, now it will come to this point and it will do 351. Okay, when this loop completes, it will be converted to this possible array. Okay, fine. And I can see that this array is lexicographically greater, but not the greatest possible. Greatest possible is 531. So again, I will start from this point and I will check the condition again, so I can see that it is possible to swap. So I'm going to if this is a function, let's call it function. Okay, and which takes array as input and n the size. Okay, so I'm going to call the same function again. I will call function which is going to take new modified array, which is 351. So I will return this. Okay, now I hope the approach is clear to you. It is actually, you can also solve the same problem using iterative approach. Okay, so I will show you the code and you can figure out from the code how we are going to solve it. Okay, so this is the code. Let me start from the recursive code. So the recursive code says that, okay, so we can modify this code. I will tell you how. Okay, but before that, I want to tell you one more thing, that you will ask me at which point we are going to stop. Since it's a recursive function, so a recursive function must have a base condition. So what is that base condition? Okay, so I will say the base condition is that when it is not like this condition is not true, so I have not swapped any number in the array. So if I have not swapped any number, at that point I'm going to stop. Okay, fine. So like if I have the array 531, so condition is not true for this, not true for this as well, so I will not like swap anyone. Condition is not true because this is one more thing that we have to satisfy. Okay, so for this array I have not performed any any of swap operation, which means that this is the maxi like greatest lexicographically greatest array possible. Okay, fine. So that's why at this point I'm going to return, like, if my swap is equal to 0. So at this point, I will check if my swap is equal to 0, then I have to stop. I mean, instead of calling this recursive function, I will return the array itself. Okay, fine. Now let me show you the code. Okay, so on the left hand side I have the code, and I'm going to have a boolean variable which is swap equal to false initially. Okay, fine. And whenever I swap two numbers, then I have to make swap equals to true, that it says that yes, I have swapped at least one element in the array. Okay, and this is the base condition. If swap is equal to false, like I have not swapped any number in the array, in that case I have the like greatest array possible, so I'm going to return that array. Even let me write a. Okay, fine. And I can, okay, and after that I'm simply going to call the recursive function. Okay, you can even modify this code as well. In this code again you are going to have a boolean variable which is bool. Okay, so you can do it yourself. I'm not going to modify the whole code. So this is how you are going to do, like the same way I have done here. Okay, fine. Now let me talk about the iterative approach. Okay, so the iterative approach shows that uh, I have a boolean variable, and instead of calling the recursive function I have while loop. Okay, and this while loop again says that I have swapped equals to false, and when the swap is equal to true, then I have to like again call this same loop. okay, and it's keep calling on loop until swap is equal to false, okay, and after that it is going to return the array. The same thing I am doing here as well. So this was about the brute force approach. But okay, let me talk about the time complexity of this approach. So I'm calling this function again and again. So the first operation that I'm doing is an O of n operation where I'm traversing the whole array, like O of n operation where I'm traversing the whole array. But apart from this, I'm also doing O of n operation outside this, which is the recursive call. Why this is, how this is O of n operation? This is the question. Okay, so let me take the array which is 1 3. Okay, it is going to 1 3 7. Okay, it is 1 3 5 7 9. So for this, when my loop completes first time, so the output will be, okay, so output will be 35791. Okay, and after that, when this loop completes second time, then the output will be something like 57931, and then it will be 79531. After that it will be 97531. Okay, so you can see that it's like calling the same loop again and again. Why? Because the 9 is the greatest element possible, and since the condition is true for all the elements, so this 9 will keep moving to the left, and when this 9 comes to the leftmost possible uh, like index, then it will be the lexicographically greatest string, like string or array possible. So it is again going to move O of n. So this is the example. Okay, fine, and now the complexity is going to be O of n square. Okay, so can we do something optimal? Yes, we can do something optimal. So let me talk about the optimal approach now. Okay, so here we have the optimal approach. Let me take the same array that I have explained you. Array is, I have 1 3 5 7 9. Okay, for this array you can see that the condition is true for all of these. Okay, so when this loop is going to stop, this loop will stop when this 9 reaches this position. Okay, this 7 reaches this position, this 5 are okay, it will remain at the same position. Okay, and after that this 3 will reach this position and this 1 will reach this position, so it will be 97531. Because I can swap any adjacent element, so I will keep swapping until it reaches this position. Again I will do the same for this 7. Okay, so isn't it similar to the like sorting this array in descending order, isn't it? Okay, so it is similar, but instead of sorting it in O of n log n, like n log n, I'm sorting this array in O of n square. This is what I'm doing in the brute force approach. I'm calling the same function again and again. Okay, fine. So we can do the same task with O of n log n. So the complexity of this approach is going to be O of n log n. Why? Because we are going to perform the sort operation. But how? Like, what is the way we are going to use in order to like sort the array? Okay, so if I have array like 1 3 2 9 7, then I have to set some bounds. This is the first index for which the condition is true, and this is the first index for which the condition is not true. So I can say that from this index to this index the condition is true. Okay, even I can write 5 here as well. So I can say that for these three like for from this index to this index j, the condition is true, which means that this 5 can come to this index, this 3 can remain okay at the same index, and this one can come to this index. Okay, again I can see that for these two condition is not true. Okay, and now for like these two, again condition is true, again condition is true. You can see that the sum is even, which is 16, and this element is greater and this one is smaller. Okay, okay, so even let me write like here 7 9 and then 11. So for these three, again you can see that the condition is true. Okay, so I'm going to write I and j. Fine. Now, instead of moving 5 first to this index, then to this index, I can like directly swap, like sort this. Okay, so I will do something like I will make it 5 3 1. Okay, and after that this 2 will remain same, and after sorting this part I will get 11 9 and 7. So this is going to be my output. So instead of iterating over the array again and again, and or I mean calling the function again and again, I can do some like simply sorting for the condition where my like for the continuous set of index for which the condition is true, because I know from this j to I can move the greatest element. So why not to do it in O of n log n, like n log n. Okay, now should I write the pseudo code? I'm not sure, but okay, so let me show you the code directly. This is the optimal approach that I have. So I'll start with the C++ code because it is comparatively easier to understand, and then I will move to the Java code. So I have C++ code on the right side. I'm starting from 0 index. After that, while my I is smaller than n, I'm starting from the next index of I, and then I'm finding the index j in which the condition is true. Okay, so here you can see that when this loop completes, when this loop completes, so I will have a set of index I to j for which the condition is true. This is what we have to find. Okay, and when we have found the index, then we are going to sort the array from I to j in descending order. In descending order. Okay, and after that I will move to j. Okay, fine. So this is what we are doing, and even you can see like in the board as well, we will start from this I, and then we will find the index j for which condition is not true. After that we will swap, like, okay, after that we will sort this particular array in descending order. This is what we have done here. Okay, fine. Now talking about Java code, so here you can see that in Java code we are doing it in two steps. What are those two steps? These steps are: first I am sorting the array in ascending order, and after that I am reversing the array, because there is no direct way of sorting the array in descending order. Okay, fine. But it is only for primitive data types. If I have something like integer, like I have integer class which is a wrapper class in Java, so I can directly sort in descending order. Okay, but we have like primitive data type which is int, so that's why we are doing reverse operation. So I don't think we need to, like, I need to show the code for reverse operation. This is the code for reverse operation. We just where we just keep swapping the first and last element. Like if I have something like 1 3 5, I have 1 2 3 5 and 7. So I will first swap this 7 and this 1, after that this 5 and this 2, after that this 3 to this 3. Okay, so it will be like 7 and 5, and then I have 3 2 and 1. So this will be the output in that case. Okay, fine. So now I hope the problem statement is clear to you too, and the intuition and the approaches are also clear to you. So this is all about this problem. Thank you.